Okay, a couple of aspects I wanted to mention while we had the Science Channel up is our schedule has changed. We're going to work on papers a little bit today. If you did look at plan book before today, it said problem quiz for tomorrow, which has also been changed. We will have two of those evaluations on Thursday and Friday. Okay, one of them is just balancing. Then the second one would possibly be what, do you think? No, that's tomorrow. Vocab quiz tomorrow. So Thursday is balancing only, and then Friday would be what?
The rest of the equation.
True.
Like this plus this arrow.
Because what are your papers dealing with today?
Naming the types of reactions.
Right. So Friday would be classifying the reaction, which can include finishing the equation, but also balancing it as well. Some people are really good at balancing. Other people, maybe not quite so much. Okay? So, moving forward then. Okay?
Negative, and then the other one is the negative charge. It's in front of the other one.
Yeah, always put the positive charges first. Okay, so with that, what do you think is the most difficult part? Have we been able to move on from the balancing? Is that easy? Well, not easy, but we're getting a pretty good handle on that. Yes?
I was answering your question.
Oh, okay. So to me, probably the most difficult types of reactions are the ones that are already classified for you, but you have to finish them. Okay? So, someone give me a metal.
Zinc. Iron.
Indium.
Okay, and now I need a negative ion.
Bromine.
Okay, now I need another compound here with, per se, a transition metal and a polyatomic ion.
Potassium.
Phosphate.
Phosphate.
Okay, so said phosphate, so we'll put him over there.
Phosphate and aluminum.
Okay, so phosphate. Okay, so what are we putting in front of the phosphate ion?
Aluminum.
Okay, we wanted a transition metal with multiple charges.
Cobalt.
Okay, so what type of cobalt? Now, you laugh at this, and I won't be able to point this time out in history, but this still happens for general chemistry students. We're going to see that. Okay? Again, you can laugh at that if you want, but why is that wrong?
It's not how many cobalt, it's the charge.
It's the charge of the cobalt. We don't have to make you guess what the charge of cobalt is. We are telling you what the charge of cobalt is. Now, with this, what type of reaction, if you have a really, really good understanding of this, you can tell me what type of reaction this is already.
Double replacement.
Why is that right?
Because you're switching out two
Okay?
things.
We have two compounds here. Because if this was not a double replacement, I'm just going to put this up here right now, double replacement, okay? What would happen if we did this?
Single replacement.
Now we got a single replacement because we have a lone metal all by itself. And that would become more apparent once you start writing out the formula here. Okay, so regardless, this is what we have. So, what is the symbol for zinc? Okay, and notice, why is there not a Roman numeral 2 after zinc?
Because it's the only charge it has.
It's the only charge it has. It's not that we would ever count off for this, but I see students doing this from time to time. They will write this out and say that. It's not that that is incorrect, but what's wrong with that?
You don't need it.
You don't need that Roman numeral 1 because how many different types of charges does potassium have? It only has a charge of +1, so you don't need that Roman numeral. Okay, so regardless, we've got zinc, and then what's the chloride ion? What's the chloride ion? Okay, do you want to write out everything first, then come back and balance out the compounds, or you want to do that as we go? Okay, what's the charge of the chloride ion? There's your -1. What's the charge of zinc?
+2.
That does not add up to 0. Okay? Who is being proficient with that? Do we still struggle with this? Okay? So how did we get from this to this?
You gotta make it equal.
Well, I know you got to make it equal. You got to find the least common what? Least common multiple, which people still do this. There's nothing wrong with that. 2 is the least common multiple. The answer that you get is what you put below. Okay? So 2 divided by 2, we've already got 1 zinc atom. 2 divided by 1 gives you 2. That answer tells you what to put below. Okay, so then we've got what is the symbol for cobalt?
CO.
What is the symbol for the phosphate ion?
P, capital O.
Is that it?
No, you need a 3 next to the O?
PO. PO.
PO3? Okay.
PO4. PO4.
4.
Well, is it 3 or is it 4?
It's 4.
Okay. See, and the reason we do that, okay, is because if I keep telling you, no, it's 4, no, it's 4, when you keep thinking that it's 3, but I keep correcting you, you are not going to learn that way, okay? It's kind of like if you are a point guard in basketball, or if you're making the same mistake in volleyball, or even same thing with marching band, okay? If the conductor or instructor keeps correcting you all the time, you're just not going to learn, okay? So, COPO4. Okay, now we know it's a double replacement reaction. What's the charge of the phosphate ion? What's the charge of cobalt?
+2. +3.
Okay, does that add up to 0?
Yeah.
So notice, one of the things that we said earlier, you laugh if you want, we're going to see this. We still see that. How many total positive charges do you have? 9. 3 times 3. Okay? We don't want that. Okay? Because that 3 is telling you what the charge is. Okay. So, playing musical chairs again. Is it because of the green color or what?
I like seeing the word.
Oh, okay.
Trying to learn.
And then Sean just wanted to. You have to.
Okay? So, the charges will not change. Put your positive ions first. So, give me a positive ion.
The end.
Okay? Now, before you say anything else, do we understand where these break apart?
Yes.
Between the positive and negative ions. So, of these 2 subscripts, are they going over there?
The PO4 is.
Why is that right?
Because it's still it's a negative charge.
Sort of. Just tell me.
It's part of the compound formula.
This 4 is part of that formula. That has to go over there. What about this 2?
That's just how many there are.
No, that's just telling you how many there were to balance out the compound. Okay, so between the positive and negative ions, so what is zinc going to bond to on that side?
Phosphate.
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 Okay?
You need 3 zinc and
Okay, so the charges do not change. Now, what is the least common multiple for 2 and 3?
6.
It is 6. Okay, so 6 divided by 2 is what?
3.
4, 3.
Okay, 6 divided by 3 is what?
2.
You need to put parentheses around.
Okay, we have 1 phosphate ion, but we want 2 of them. Okay, and then what is left over?
CO Cl plus Cl. Or ClCl.
No,
Oh,
not
no,
ClCl.
ClCl, my bad.
No,
COCL.
That's what I said.
COCl.
Yeah, then I changed my mind.
Okay,
CL again.
Oh, my bad.
does that add up to 0?
No.
Okay, no, it does not.
You need 3 chlorine.
Okay, so we need 3 chlorines. Okay, so this is plus 3, that's minus 1. 3 is the least common multiple. 3 divided by 1 gives you 3. Okay? Okay. Now, do you want to work on balancing that yourself, or do you want to do that together? Okay?
I'd like to do it by myself.
Okay, well, take a few moments, do it by yourself. So now once you got it to this, the best thing that you can do is start giving some elements. What do we see?
Zinc.
We see zinc on both sides, chlorine, oh, well, that looks like that's lowercase, I guess, but good handwriting is certainly essential. Okay, not that mine's the best either. Zinc's left. Zinc's right. Chloride's left. Chloride's right. Phosphate's left. Phosphate's right. Cobalt's left. Cobalt's right. Okay, so obviously we can't start there. We could start there. We could start there, or we could start here. Sometimes metals is the best place to start. You have 3 zincs on the product side. How many zincs on the reactant? So what would we put there?
Can you make that even if you want though?
3 zinc.
Can we make that even?
Yeah.
What's that? This here?
You make the zinc on the right side 6.
No.
I would not suggest that, because typically what can happen is, one of the things I'll guarantee you I'm going to say is, yes, I will lend you $100 anytime. You're going to pay me back at 100% interest when you do that. So not only are you paying back that principal, but you're also paying back 100% of that loan, which means I lent you $100, you're paying me back $200. Well, no, we're not loan sharks here. So regardless, okay, you have 3 of these on the left, or excuse me, 3 of those on the right and only 1 on the left. So what should we do? Let's try a 3. Sometimes it's trial and error. Okay? So we put a 3 here. 3 times 1 is 3. 3 times 2.
6.
Okay?
Put a little 2 over there.
So then we can look at your phosphates or your chlorides. You pick. Chlorides, okay? So we got 6 chlorides on the left, but only 3 on the right. So what do we do?
Put a 2 in front of that.
So once we put a 2, how many cobalts is that?
2.
How many chlorides is that?
6.
Okay? So now, once we see we've got 2 cobalts to 1, if we put a 2 here, 2 times 1, and 2 times 1, is everything balanced? Okay? 3, 2, 1, 2.
That was beautiful, guys.
Okay? 3, 2, 1, 2. All right. So keep in mind, your papers are due tomorrow. So I'm going to hit pause for just a moment. We have deliberated and we decided
When Isaac did this.
everyone has a good understanding, so the rest of the time is yours. We'll catch up to you next time. Papers are due tomorrow and vocabulary quiz tomorrow. And we have 2 problem quizzes at the end of this week, Thursday and or Friday. We'll catch up to you next time.